This section 1.4 is called Rewrite Formulas and Equations. The emphasis here being that often it is more efficient and effective to isolate the variable before plugging in values. They initially ask you to plug in values and then solve for the variable. So for example, number 2 looks like this. 3x plus 2y equals 10, and then they give you a value x equals -2. So in this case, they say plug in the value and solve. I didn't do something right there. 3 times -2 is -6. Add 6 to both sides. Y is 8. Oh yeah, y is 8. So 3 times -2 is -6, plus 16 is 10. That works. So yeah, in this case, I plugged in the value and then solved for y. In the next set of cases, they ask you to solve for y and then plug in x. 3x minus y equals 3. So I want to get y by itself. So I'm going to subtract 3x from both sides. And however you want to write this, 3 minus 3x, or I'm sort of thinking about y equals mx plus b, so I put the -3x first. Doesn't matter because it's addition. Addition is commutative. Now I need to undo that negative, so I divide each value by a -1. Another way to look at it is if I change the sign of y, I have to change the sign of x, and I have to change the sign of the constant. Now I can go ahead and plug in my 2, and y equals 6 minus 3, so y equals 3. And I should check 3 times 2 is 6, 6 minus 3 is 3, that checks. So here I'm plugging in the value first, then getting y by itself, but the practice here is really to get y by itself and then plug in the value. And this is somewhat common. I would call this standard form, and this is intercept form. To rearrange an equation to find certain parameters of that equation. This one's a little tougher. Often I see an xy here. Often we can factor out a value. That doesn't seem to be happening here. We are pretty early in Algebra 2. So if I want to get y by itself, I first have to undo this guy. So I'm going to subtract 2x. And I'll leave it in the order that I'm doing the operation this time around. -6 minus 2x. And then if I want to get y by itself, I need to divide by 3x. And I'm dividing this whole thing by 3x. Now, over here, notice I divided each term by -1. I could have done that here, but that would be more complicated in the end when I go to plug my value in. So y is all I'm left with here. This is what I get on the right-hand side. Now I can go ahead and plug in my 5. Y equals -6 times -2 times 5 over 3 times 5. That's -6 minus 10, which is -16/15. I don't care to plug that back in and see if it all works out. I could, but in the interest of video brevity, I won't. You can check the answers as you guys have them as well to see if that's correct. Really, again, where this strategy is more effective is when you're solving for formulas. So here's the formula, circumference equals 2 pi r, or the relationship. And they want us to isolate r. Maybe I'm going to do a lot of problems where I'm looking for r and I'm given the circumference. So I divide both sides by r, and I get r equals c over 2 pi. Here is the area for a trapezoid. That's a little more complicated. Area is 1/2 the sum of the bases times the height. And in this case, I'm trying to get the height by itself. So I have a product going on here. I have this times this times this, an x times a y times a z, if you will. And I need to get z by itself. So the first thing I need to undo is the 1/2. Well, how do I undo multiplying by 1/2? Please do not say divide by 1/2. I'm going to multiply by 2 over 1. Multiply by the reciprocal. Undo a half by multiplying by 2. So I get 2a equals this quantity times h. And if I want to get the h by itself, I have to divide by that quantity. The parentheses are important. So I double the area, divide by the sum, and I will get the height.